All right, we've got our rationals unit test coming up. We're going to go ahead and go through pretty much all the concepts that you guys have studied in this unit. The first thing we did was we graphed what we called simple rationals. They all look like, it doesn't have to be one, I guess I could say some value x minus h plus k. These move the same way as any other function moves. So if I see an x minus 2 on the inside of parentheses, that means it's going to go right 2 and up 2. Now, what's actually moving right 2 is the vertical asymptote. So x minus 2 helps you figure out that the vertical asymptote is at x, what's going on there? X equals 2, right here. That's the vertical asymptote. So when it says vertical asymptote, I'll say it went right 2, x equals 2. What's actually moving up to is the horizontal asymptote. So y equals 2, and I have a horizontal asymptote there. Now, we've talked about making a table, but you can use Desmos as well to help you figure out how the function looks. So I'll graph it, 4 over x minus 2 plus 2. Yeah, that's it. And I'll just see if I can find a nice ordered pair. It looks like 4, 4, and 0, 0 are points. So 4, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 0, 0 right there. And when you draw it, it just looks like this. It follows along the asymptotes. It goes down, and it goes over. Something like that. The domain is all the x values. So if you see all the x values, you can see this thing goes forever to the left, negative infinity 2, and then at positive 2, I have to pick up my pencil. That's because you cannot divide by 0. If you plug in positive 2, 2 minus 2 is 0, you break the function. But we also have this side, so we'll say union, start at positive 2, and then it goes forever to the right, 2 to infinity. So from negative infinity to 2, pick up your pencil, 2 to infinity. The range is very similar, negative infinity to 2, pick up your pencil, and then 2 to infinity, because they both have 2 as their values for the rest of those. So those are the simple rationals. Then we have these more generic rationals where you have a fraction, but there's no like plus or minus here. It's already been condensed into a single fraction. The first thing you need to remember is the vertical asymptote is when the denominator equals 0. So that would happen when x is negative 3. So at negative 1, 2, 3, right here, that's our vertical asymptote. The horizontal asymptote depends on the degree. Here, the degree of the numerator is degree 2, and the denominator is degree 1. So since the numerator is a higher degree, this actually doesn't have a horizontal asymptote. It has a slant asymptote. And I'll show you what that looks like when we actually have the graph, but let's see if we can see it right here. Whoa, that one. Wait, that one. Ah, we found it. Okay. So you can see how this thing doesn't have a horizontal asymptote. It has a slant asymptote. And you can usually figure out what it probably is. I'm just going to try and guess. It looks like, let's see, y equals x. Maybe let's try minus 1, minus 3, minus 4. Looks like it's a minus a lot. What's the y-intercept? Let's maybe like 10. 10? X minus 10? That might be it. I think that's probably pretty close. Okay, you can see that there's an asymptote. It's a line, y equals x minus 10. I think that's it. Okay, so I found the asymptote. And as you zoom out, it looks like the function actually becomes a line. It doesn't. It approaches that. That describes the end behavior. So when I draw this thing, I don't need to draw that perfectly. It's going to look something like this. The slope is 1. I'm not to scale anymore. So when I draw it, I just need to know sort of where it is. It's going to follow this vertical asymptote and then go to the slant. And down here, it does the same thing. It follows along the slant, and then it goes down to the vertical asymptote. So it looks something like that. Now the domain here, you still can't plug in negative 3, so negative infinity to negative 3, union negative 3 to infinity. There's a vertical asymptote, so negative 3 is not in the domain. But the range, it does go up and down forever. There's a bit of a gap here. Let's not worry too much about that. And we'll say, well, we can look at it here. Actually, the range is negative infinity to negative 26, and then negative 1 to infinity. So we'll say it's about negative infinity to negative 26 point something, union negative 1 point something to infinity. I don't want you to get too hung up on the range. We haven't done a whole lot of this local min, local max stuff here, but I think it is worth at least kind of exploring. Rationals. So when you are multiplying, and notice there is a multiplication symbol there. When you are multiplying, you can make this one big fraction, and the game is factor, 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 factor. Factor everything you can, and then if any factors cancel out, great, it'll simplify. So top left, I'm going to factor out a GCF of 3x, and I have x plus 2. Bottom left is dots, x plus 5, x minus 5. This, I'm going to try and guess and check. We'll see if I can guess and check this thing. What multiplies to negative 10 and adds to 9? I think I need negative 10, no, positive 10 and negative 1. So 2x squared plus 10 minus 1, that works. And then bottom right, you can always do split the middle if this doesn't help. Plus 4 would be 2 and then minus 1. 2x squared plus 4 minus 1 minus 2. Again, if you have trouble factoring these two, just do split the middle. Split the middle for those two, but you get the same factors. Once you get it all factored, you see what cancels. Does anything cancel? X plus 5? Yes. X plus 2? Yes. 2x minus 1? Yes. So the only thing that's left is 3x over x minus 5. That is completely simplified now. You factor everything you can, and you cancel any of the factors that are shared in the numerator and denominator. Division is very similar, but there's the first step of copy, change, flip. So you need to make sure that you copy the first part, x squared minus 7x minus 18. This doesn't change. But now I'm going to change to multiplication, and now it's 50x squared minus 2 in the top, and 5x squared plus 9x minus 2 in the bottom. I'm going to do the same thing where I factor them, and you guys can do split the middle if you want off to the side. Now that it's multiplication, this is one big fraction. So when you factor top left, you get x minus 9, x plus 2. When you factor bottom left, let's see, I want negative 15 and 1. So how do I do that? Negative 15 and 1, that'll do it. This guy has a GCF, so if you factor out a 2, you have 25x squared minus 1. So I first factor out the 2, but that's dots. So this would be 5x plus 1. 5x minus 1. And in the bottom left, I'm going to try and factor to my head again. I want 10 and negative 1. That'll make positive 9. Does anything go away? I'm sure something does. X plus 2, 5x plus 1, 5x minus 1. So I have 2 times x minus 9 over x minus 3. That one's simplified as well. So we're moving along. We've done multiplication. We've done division. Next up is addition. Addition's a little fancier. These need to have a common denominator. When you're adding, you need a common denominator. So the first step is figure out what each denominator is sort of made up of by factoring it. So in the bottom left, I have dots. X squared minus 9 is a difference of 2 squares. This helps us see that they both share an x plus 3, but this guy also has an x minus 3. So give him an x minus 3 in the top and the bottom. Now my denominator is not going to change for the rest of the problem. It's going to be x plus 3, x minus 3. And it's important you remember that when you're simplifying, this does not go away. You need to keep the denominator. When you're solving, you can cancel it out. We don't have an equal sign, so the denominator is going to stay the same. All you need to do is simplify the top now. 5 plus, when you FOIL, you get 3x squared minus 9x minus 5x plus 15, and we'll simplify. We got 3x squared minus 14x plus 20 over, again, my denominator does not change, but it is part of the solution. That is simplified now. Okay, let's try some subtraction. Basically the same game. They need a common denominator. So this guy's got a 3, this guy's got an x. Their common denominator will be 3x. So he needs an x, and he needs a 3. Now we have something over 3x. What's in the top? 2x squared minus 9 times 3 is 27, and you're done. That's it. Addition and subtraction are pretty much the same thing. Sometimes you have a negative to distribute. Complex fractions, or compound fractions, however you want to call them. You need to have a single fraction in the top, done, and a single fraction in the bottom, not done. So in the bottom, I'm going to multiply their denominators. This guy needs an x, and this guy needs an x plus 4. So I'm not doing anything in the top. 3 over x plus 4. But in the bottom, I'm going to condense this to be something over x times x plus 4. I'm just looking at the top. What's in the top here? You have 2x plus, when you distribute, 5x plus 20. So that'd be 7x plus 20. Once you have a single fraction over a single fraction, you can copy, change, flip. 3 over x plus 4 times the reciprocal, now this is in the top, and that is in the bottom. That's 7x plus 20. Now you see if anything cancels, and it looks like x plus 4 is going to cancel. So you're left with 3x over 7x plus 20, and now that is simplified. You got to condense the top and the bottom to a single fraction, then you copy, change, flip, and if something goes away, great. Proportions. Okay, so when we solve, we have a couple different scenarios. If you have a fraction equals a fraction, and there's an equal sign there, you can just cross multiply. So when I cross multiply, I'm going to multiply 2 times 3x minus 1, and I'm going to multiply x times 5 minus x. Now I can distribute on both sides. 6x minus 2 equals 5x minus x squared. When you distribute here. Get everything on one side. Let's move it to the left side. I have x squared. If you subtract 5x, now it's 1x. And now we're going to factor. So what multiplies to negative 2 and adds to 1? That'd be 2 and negative 1, which means x either equals negative 2 or positive 1, or does it? It does. So the extraneous solutions would be when x equals 1/3 or when x equals positive 5. Both of these are okay. Whoa. Both of those are okay, so we don't need to worry about extraneous solutions. Now, when you are solving, you should absolutely graph it to check your answer. So what I've done, I think, is graph this one right here. The way you graph it is you treat it like a system. Graph the left side and graph the right side. So x over 3x minus 1 and 2 over 5 minus x. X over 3x minus 1, got it. And what should happen is we're treating like a system, so we're finding the intersection points. I think that these two functions should intersect at negative 2 and positive 1. Do they? Negative 2, positive 1. Sweet. I know I did it right because I verified my answer visually. Let's try another one. Here you can't just cross multiply because this isn't one fraction. So we need to get a common denominator. Negative 3 over x minus 4, that has an x minus 4. X over 1, he needs an x minus 4. So we'll do x minus 4 on the top and the bottom. And on the right side, this already has an x minus 4. Now that everything in this entire problem has the same denominator, what you can do is you can multiply both sides by x minus 4. And if you do that, what happens is all of these factors cancel out, and you're only left with the numerator. So all I'm focusing on now is the numerator. I have a negative 3 plus x squared minus 4x equals 6. Now it's a whole lot easier because all you gotta do is get everything on one side. X squared minus 4x. If you subtract 6, you'll have negative 9. I feel like this is going to be messy. Let me see if I've already, before I get too far into this, let me see if I've checked it, if the answers are nice, or if I've made a mistake. Uh-oh. This looks like quadratic formula. I didn't realize this is a quadratic formula problem. That's okay. We're going to grind it out. Quadratic formula, b squared minus 4ac is 16 plus 36. That's 52. So I have the square root of 52, which is 2 times 26, so that's 2 radical 13. So my answers are the opposite of b, 4 plus or minus 2 radical 13 over 2a, which I'll condense to 2 plus or minus radical 13. Let me just see if that's right. 2 plus or minus radical 13. 2 plus radical 13 is 5.56. Or 5.6055. Yeah, that looks good. And 2 minus radical 13 is negative 1.6. Sweet. Okay. So if it's not factorable, you got to do quadratic formula, and that's something you should be able to do. So 2 plus or minus radical 13. We got one more, And this one has a common denominator, or doesn't have a common denominator either. So first thing I'm going to do is let's see if we can figure out what our common denominator will be. And the way I'm going to do that is I'm going to factor the only one that I can factor, that's that one. So the numbers that multiply to 6 and add a -5 are -3 and -2, which means, oh look, this guy has an x minus 3, so he needs the other one, or has an x minus 2. Now he has an x minus 3. Now he has an x minus 2. And now that everything in the problem has the same denominator, you can multiply both sides by that denominator and eliminate it, and now just focus on the top. So in the top, I have x squared minus 3x equals 5x minus 10 plus 10. And these cancel out. That's cool. Now when you get everything on one side, you're going to subtract 5x, and -3 minus 5 is -8. And people get stuck here. When you have x squared minus 8x, you need to just do the GCF. X minus 8. So x either equals 0 or x equals 8. Or does it? Can x equal 0 and 8? I think so. It looks like 2 and 3 are my extraneous solutions. So let's check it on the graph. 0 and 8, do those both work? When I graph it, graph, 0 and x equals 8. Yeah, 0 and 8. Great. So we did it right. X equals 0 and x equals 8, and they are both actual solutions. There are no extraneous solutions here. So if you can go through all those concepts, you should be good to go on the test. Good luck.